This is problem 28 from the Open STAX chemistry textbook. You can use torr. I'm going to use millimeters of mercury in solving this problem, okay? So let's think about this. What is the temperature of an 11.2 liter sample of carbon monoxide at 744 torr if it occupies 13.3 liters at 55 degrees Celsius and 744 torr? So what we have is a volume. Okay, so we have two volumes here. All right, we have two volumes. And we have one temperature. Okay, and they're asking us for a different temperature. Okay, so we have two volumes, V1 and V2 we'll call it. We have two temperatures, T1 and T2. Okay, and we also have two pressures, but they're the same. Okay, if the pressure is constant, we don't need to indicate what is P1 and what is P2 because they're equal and they're going to cancel out. Okay, so if it's constant pressure, we don't use it, okay, because the pressure is not changing. Okay, so if we have two volumes and two temperatures, we know that we must use this Charles law here. Okay, so we're going to use this formula here. But let's first identify what is V1 and what is T1 and so on, okay? So what is the temperature of an 11.2 liter sample of carbon monoxide? Okay. So that's, I'm just going to call this initial condition, or T1, okay? It could be T2, it doesn't matter what it is, okay? But you want to keep your ones together and you want to keep your twos together, okay? So I'm going to call this temperature right here T1, and that's unknown, okay? What is the temperature of an 11.2 liter sample of carbon monoxide? So that's the volume that goes along with that temperature, okay? Now, T2 is over here. I'm sorry, V2 and I'm sorry, why did I? Yeah, okay, so getting a little discombobulated here. So there's a comma here in the sentence. So if it occupies 13.3 liters, okay, so we're going to call this over here V2, 13.3 liters at 55 degrees Celsius, okay, and 744 torr. Okay, so that's T2, which is 55 degrees Celsius. Now remember, right away what you want to do here is add 273 to any Celsius temperatures that are provided to you, okay, to convert those to Kelvin. Okay, so 55 plus 273 is going to be equal 328. Okay, 328 Kelvin. All right, so we have one equation over here, and we have variables and one unknown. So let's get started on this situation. So we got a V1 over T1 is equal to V2 over T2. And what we want to solve for is T1. It's right here. Now I use a technique that I learned way back in elementary school, and that's called cross multiplication. So I'm going to multiply this diagonal, okay, which is T1 V2 is equal to V1 times T2. Okay. Now, that gets rid of fractions, so that's very good. And again, we want to solve for T1. So now I'm going to divide both sides of this by V2. Okay, it cancels out here. And I've got a new formula now. T1 is equal to V1 T2 over V2. Okay? And let's go ahead and plug this in. All right? So V1, let's find it on this page, is right here. It's 11.2 liters. Okay. T2, it's right here. It's 328 Kelvin. Okay. Divided by V2. What is V2? V2 is right here on the page. It's 13.3 liters. Okay. And it's very important to make sure that your units cancel. You can see here that the liters are going to cancel. Okay. So Okay, so you want to take your calculator, 11.2 times 328, and divide it by 13.3. All right, and we get a value of 276. Okay, and that's in units of Kelvin. And that's great because everything here in my formula has 3 significant figures, okay, 11.2 and 13.3 and 328. So that's 3 sig figs. And I'm just going to leave it there. The problem doesn't say what is the Celsius temperature. It just says what is the Kelvin temperature. If ever you have a problem that asks you what's the Celsius temperature, you subtract by 273, and you're going to get 3 degrees Celsius. So that's pretty cold, okay, pretty chilly. Thanks for watching, and please do consider supporting my channel by clicking that subscribe button or liking this video. It's completely free. Thanks, and have a great day.